transformations, and then we're going to fill out a transformation table, which we did a little bit of already. We just haven't done this many steps. So I'm going to zoom in a moment so you can copy down what's there. And then we're going to graph. And we've already done graphing as well. So the first thing I want to do is I want to zoom in right over here, and we're looking at the equation. And over here I wrote PF, which stands for parent function. You can look over there, but nobody handed me your phone.
No, folder.
Oh, folder. I don't know. Look. Nobody said here's a folder.
Okay.
Sorry, I'm making a video right now.
Oh,
Okay. So PF stands for parent function. PF stands for parent function. And we look at this equation and we look to see, is there absolute value in this equation? Any absolute value bars? No, so it's not absolute value. Is there like a little squared, little tiny 2 up there? No, so it's not that kind. If there's nothing other than like the x, the absolute value, or the parent function is just x. Oops, I didn't mean to make that pink. I meant to make that black. There we go. So our parent function is just f of x equals x. That is what shape when we graph it. Line. This is a line, okay? Then what we're going to do is we're going to look at our transformations. And our transformations, the order doesn't matter, but I'm always going to write them down in the order from left to right through the equation. So the very first thing that I come to that isn't just x is the negative sign. So negative always means what? It always means reflect. You can write reflection as well. And then it's always going to say after that, in the. And then we have to determine which axis that is in. Closer out. Come in just for a second. I'm going to have you put your phone and smartwatch here. Leave anything here except for your computer. And then you need a desk. I'm going to put you. Do I have to write anything? She'll work. Oh, that's fine. Let me take this desk. Give them then. Tell me when you're ready for the password. I'm thinking this video might have to be done. Unless somebody can show me on WeVideo how to take out part of it. No, not right now. Okay, reflect in the. So you have to know which way to reflect. Is this vertical or horizontal? So we look at the negative sign. Is that on the inside or the outside of the function? Outside. And anything outside is vertical. So I know this is going to be a vertical reflection. So you can't, on the video, you can't see me like waving my hand up and down, but you just imagine like some sort of reflection up and down. So it's vertical. Which axis would that be reflecting over? The x-axis. So that's what I'm going to fill in here. Yes. Yes, because it's on the outside of the parenthesis, exactly. And then the second thing we come to is this subtract 2. Is that on the inside or the outside? It's on the inside, and anything inside is horizontal. The words would be, or the blanks would be blank, blank. Oh, I didn't leave space on one. It would be blank, blank, blank units. Anytime we add or subtract, that would be a what? What's the word? Oh, it is horizontal, but that word is translate. And which direction are we translating? Right. And remember, everything horizontal is opposite. And then that would be 2 units. If you have any questions, okay. All right, and then finally we have a +1. And is that +1 on the inside or the outside? Okay, outside is vertical. We'll have blank, blank, blank unit. And so our fancy word is translate. It's going to be 1 because it's vertical. Which direction are we going? Up, because that one's the common sense. Because it's plus, I'm going to go up. So those are all our transformations. So now I'm going to zoom in so you can see what my words are in my table and copy down my table. I'll give you a moment to get the table copied down, and then we'll fill it out together. So there are 2 middle columns, and that's going to be X and Y. And then there's 2 columns on either side. At the very top of the columns, I've written multiply and then add or subtract as you work your way out. In the X column, I went and wrote the numbers that we so far have always used for X's every single time. We've been using -2, -1, 0, 1, 2. The Y I haven't written down yet, but I always write the parent function with that Y column so I remember what Y values to use. So we already wrote it down. It was f of X, or Y equals X. Okay, that's my parent function. So to know what to put in the Y column, we use the parent function. So if I put in -2 in for X and Y equals X, then Y is also -2. If I put in -1 for X and Y equals X, then X and Y are the same number every single time. This is an easy one to fill out. Okay. You can memorize these numbers and not actually think about what they are, but you have to know which ones go with what, because these are the only Y values that we would use for Y. Like Y equals X only has these Y values. If I do absolute value of X, it's different Y values. It changes by what the parent function is. So you can memorize it, or you just think about putting it into that parent function. At the very bottom, I am showing you how half of this table is all vertical stuff and the other half is all horizontal stuff. So if you're writing that down, if you're copying it down, these are just the notes. This is not something you wouldn't have to write vertical and horizontal every single time you do this. You would just fill out the table. So the vertical, horizontal, that's to help you know what goes where. The multiply, add, or subtract, that's to help you know what goes where when you look back at your notes. Before I fill out anything here, I'm also going to graph my parent function, which we've been doing for a while. So I don't even need to, well, actually, this is a line. Maybe I need it, but absolute value, we shouldn't have to look at the table for that parent function because we've done it a lot. Oops. If you are using Kami and you can't draw straight lines, they have line tool. Saying. Okay. So now I'm going to look at the transformations we already wrote down. And that's the stuff we've been doing forever. We've been writing down transformations. Not forever, but seems like it. I'm in. Oh, no. Okay, come in. Thank you. Okay. And the first one that I come to, the reflect in the x-axis, that's vertical. And when we have a negative on the outside, like this, when we have a negative on the outside, that's multiply. So that's like multiplying by -1. You don't see the 1 there because we're in high school and we know we don't need to write it. So if you see a negative sign by itself, it's not multiplied by negative, it's multiplied by -1. Okay? So in my columns, because it's vertical, I go to the vertical side and I find where multiplication goes on the vertical side. At the very top, I'm going to write multiply by -1. If you were filling this out on Canvas, you would write asterisk or star -1. That's how you would fill it out on Canvas. So that's how I'm writing it. What's our next transformation? Horizontal, translate right 2 units. Okay, so that's adding or subtracting. To go to the right, it has to be adding, and it goes on our horizontal side. If the number in the equation is -2, why did I add 2? Because it's opposite. The words, however, fit the number in the table. The transformation that I wrote down and the number in the table, those fit each other. Those are the same. It's just the equation is the thing that's different. And then we have translate up 1 unit. We wrote down that's vertical. So on my vertical side, up is adding 1 unit. Now, in order for me to feel like I've done a decent job, using the calculator is fine, but I don't want you to have to rely on the calculator to do 2 times -1. That is a skill that somebody who has a high school degree should be able to do. Okay? So when I say, like, can't use a calculator for this part, and then you leave the room and use a calculator, you're not getting better. If you need to go and, like, learn how to multiply -2 times -1, I can help you. We can do, like, an iExcel assignment for that. But, like, we don't want to have to rely on that. Now, if I'm talking about let's multiply 232 times 37, like, yeah, I would use a calculator for that in real life. But I would never pull out a calculator to do, I don't know, 2 plus 1. Okay? So if I'm giving you questions and they are easy numbers, because I'm doing that for you, so you don't have to use a calculator, let's try to do it without. All right? So what I'm going to do first is I'm going to multiply all my y values by -1. That just changes the sign. Multiplying by -1, it just changes the sign. So we get +2, +1, 0, -1, -2. That's what multiplying by -1 does. Change the sign. Now we're adding 1. We add 1 to the blue column. We don't go back and go to the black column anymore. So we go to the blue column and we add 1. So it's literally like we're going over 1 step at a time. So my next answer is 3, 2, 1, 0, -1. So I'm adding 1 to the previous column. On the other side, we did not have any multiply, so I will just ignore that column. And I'll move to the add 2 column. Again, 2 plus a -2, or a -2 plus 2 is a life skill. Maybe you'll never ever need negative numbers ever, but I feel like to get a high school diploma, you should be able to add -2 plus 2, which is what? That was like very, very slow. 0 is correct. -1 plus 2 is 1. 0 plus 2 is 2. Oh my gosh, there's a pattern. Woo, pattern. Okay. And we go to graph these. I'm going to highlight so you can see what I use for the graph. The outermost X and the outermost Y make up your ordered pairs. I'm going to write those down because not everybody can listen to what I say and know. Some people are visual. You do not have to write these down if you know what ordered pairs we're graphing. You don't have to write them down. So those are the ordered pairs I'm going to go put on the graph. and we have the line tool. So if you need help with a straight line, and if you are doing this on paper and not using Kami, I have rulers. You could borrow one. So you could still make your straight line. Yes, Lucy. She was trying to help you out. The last thing that we're going to write down for each of these, and I'm going to zoom in, I'll zoom back out if you didn't get it written down, but I wonder if more things could interrupt my video today. Is domain and range. Hello. Sure. Bye. Toby. Okay, so just to review, our domain is all of our x's. Our range is all of our y's. So we can look at the graph, we can look at our table. How far to the left and how far to the right? The x values go to the left, to the right, and I've got arrows. How far to the left, how far to the right? Arrows mean never stops. All real numbers. Or if you don't want to write out all real numbers, you could instead write the symbol, which is what I would do if I were the student. But I'm writing both since I'm the teacher. And then the range would be how far down and how far up. And we look at our arrows. It goes all the way down. It goes all the way up. It never stops. That's what the arrows mean. So all real numbers for our range as well. Or you could write fancy R. This is what you're going to be doing for the assignment. Okay? We're going to do one more together, and then you have the rest of class to work on it. Okay, if I go too fast, remember I am making a video, and you could also tell me I'm going too fast. So I'm going to look at example B, and I'm going to think about the parent function, or example 2. Parent function, f of x equals, and I look at this equation, and do you see those bars there? So what equation is this? Parent function. Absolute value. So absolute value of x. So that's our parent function. I'm going to do the, what are they called? Transformations next. So 5 over 2, the 1/3, and the minus 2. So I'm going to come to 5 over 2 first, and you're going to decide, is that on the inside or the outside? You look at those bars, inside or outside. Outside is vertical. It is multiplied. They don't put the multiplication symbol there, but it's multiplied. So this is going to say a vertical, and then we'll fill in this word in a moment, by a, I didn't leave myself enough space, factor of, I'll just move that word vertical over. There we go. Vertical something by a factor of something. Since it is vertical, it's common sense. We don't have to switch anything. 5 over 2 is the factor. And then you have to determine if 5 over 2 is going to make it bigger or smaller. Is 5 over 2 bigger than 1 or smaller than 1? Couldn't hear you. Bigger than 1? Here's your step. Will you just push the chair? It doesn't even have to go all the way back. Just push it in the classroom and we'll finish. Okay. Bigger than 1. So it is, by the way, 2.5, 2.5, so you know. So this is going to be a stretch. Next is 1/3. 1/3, is that on the inside or the outside? I'm sorry, I did not hear. Is that on the inside or the outside? Inside of the bars. And inside is what? Horizontal. My thing stopped working. There we go. And so we're going to do a horizontal something by a factor of something. I know it's horizontal because we just decided that. We will figure out if it's a stretch or a shrink after we figure out what the factor is. Since it's horizontal, are we going to use 1/3? No. What will we use? 3, the reciprocal. So does 3 bigger than 1? Stretch. And then finally, we have -2. And is -2 on the inside or the outside? Outside. Outside is vertical. So this would be translate. Oops. Down 2 units. I'll make my transformation table. Oh, finally they called me. Sorry, guys. I don't know what's going on with the interruptions, the nonstop interruptions. All right, so we got X, and then we're going to have Y in our next column, but I'm going to put that parent function, which is absolute value of X. We already determined that parent function was absolute value of X. I'm putting it there so that when I put my X's down, I can easily figure out the Y values that go with it because it has to be the absolute value of the X values, which makes everything positive. And we've done this so much that you should be able, if you've been doing anything in this class, you should be able to graph those now without even looking at the numbers we wrote down. Am I okay so far? Like to go on? Cameron, you okay? Okay, so now we're going to do the transformation table. So I'm going to look and see what transformations I wrote down, and I'm going to put those in their correct columns. So the very first thing I wrote down was a vertical stretch by factor of, and then a horizontal stretch by factor of. And what does that factor of mean? Multiplication. So we've got a vertical multiplication, we've got a horizontal multiplication. What side of the X and Y's, what side does the vertical go on? On what side? The right. It goes on the Y side because Y axis is up and down, vertical. So we're going to put on the Y side times 5/2. On the X side, times 3. We always multiply before we add or subtract. So the first thing you put in is your multiplication. Then we only have one add or subtract. It is a down 2. Down is vertical, so that goes on the Y side. And then there's nothing in that last X column. And now we do very basic math. This one's a little bit harder, but let me think about 5/2 being 2.5. If we think about 5/2 being 2.5 or 2.5, maybe you can think about that being money. And I'm taking $2.50 and I'm going to multiply it by black number 2. It's $2.50 times 2. Or what's 25 times 2? What is it? 50. It's 5. It's like, think in those terms. It's pretty easy to do that fraction. So this one's 5. Now, What is 1 times 5 over 2? Okay. Other than Selena, what is 1 times 5 over 2?
5 over 2.
It is 5 over 2. Don't tell me 2.5. Tell me the number itself is 5 over 2. We can know that it's 2.5, but we don't need to say that. All right, the hard one. What's 0 times 5 over 2? I did not need my calculator for that. And then we've got 1 times 5 over 2 and 2 times 5 over 2, which we've already done. So I had to do like 3 math problems and then repeat 2 of them. Now subtract 2. So 3, -2, and then 3. Those are easy. This is where I might start to think about 5 over 2 being 2.5, and we're subtracting 2 off of it. So if I have 2.5 and I take away 2, what do I have left over? I have a half. You could think 0.5, but don't write it as 0.5 since there's fractions. Let's keep it in fraction notation. And then this number is going to be the exact same because it is symmetric. And then on the x side, we're just multiplying by 3. And then I'm highlighting for you what values get graphed. And those all become my x's and my y's. I can write them out for you, but you do not need to write them. You need to graph them. Okay? You don't have to write them. I'm doing it just because I'm the teacher, and I want to make sure everybody knows what numbers to graph, just in case you fell asleep for a second. Then finally, we're going to fill out the domain and range. So the domain is all the x values. So if I have an arrow that is pointing to the left and I have an arrow that is pointing to the right, then it goes all the way to the left, all the way to the right. How do I write that? All real numbers, or the fancy R. And if you have been in this class, you should know that answer already. The range though is different. It does not have an arrow pointing down. So it doesn't go all the way down. It does go all the way up. So the range for all of these, you guys were pretty good about remembering that it's y, and then it's either greater than or less than or equal to. And then most of you were good about figuring out that the number that goes with it is the y value in the vertex. But then a lot of you had trouble with which way the greater than or equal to or less than equal to is facing. So if the arrows are pointing up, if your graph starts with a positive number, there's no reflection. The arrows are pointing up, it's greater than or equal to. If the arrows point down, it's less than or equal to. So those correlate to which way the arrows are going. There are 2 things that I want to go over that people have had questions all day about. And so I'm going to put in the video just in case when you get to these, you could go watch that part if you needed it. One is about just question number 1 in general. Out here in front, we have a negative sign. And then we also have a 2, and those are 2 different transformations. Those are 2 different transformations. We also have the 1/2, and then we have the 6. Okay, so we have 4 total transformations, but I want to pay attention to the 1/2 and the 2. The 1/2 and the 2. The negative and the 2. Sorry, the negative and the 2. The negative and the 2, are they inside or outside? They're outside. So these are both going to be vertical. I'm not writing in the words because you should know that. But when we go to make our transformation table, that first column after the y is where all the verticals go. The first column is multiply, but we're like multiplying 2 things. You do not need 2 columns to multiply 2 things. If we're multiplying and multiplying, you can just do it at the same time. Because there's a negative 2 in front here, you can just multiply by negative 2 in your table before you do the adding or subtracting. So you don't have to have 2 separate columns, even though they're 2 separate transformations. You can just do 1 column for all multiplication, okay? So that was one thing that people had questions about. And then the other thing that people had questions about are number 5 and 6, which look kind of a little crazy, especially number 5. But number 5 and 6 have something in common. Last week, when we were graphing with our graphing calculator and we were writing equations and stuff like that, we had some example that was like 3x minus 3, and it had other things with it. And I talked to you about how if we have a number here other than 1, then this is not the translation. I talked to you guys about that last week. If there was a number here other than 1, then this minus 3 is not the translation. This is not to the right 3. But then I showed you in class, but I do not expect you to be an expert at this yet. But I showed you in class how we would have to divide or undistribute that number. And that number would be in front of a parenthesis, and we would get x minus 1 left over. And then this would be a translate left 1. No, not left, right. Sorry. I'm just writing it fast because this part's not the important part. Okay. So what I've done for question 5 and 6, I did not want to make you do this factoring step because I don't feel like we've had enough practice to just give it to you. So I'm not going to make you do that on a test either. But what I did here is already take the number out. So right here, this negative 2 out front, this is vertical. And then this minus 1/4, that's horizontal. And then this plus 1 is also horizontal. And then this plus 5 is vertical. So what I did was I already put it in this second form. It's already in this form where I have that number taken out so that you can look at that plus 1 and tell me for sure that goes which direction. To the left, and it goes 1. Okay, I made it so you can look at this number and know that's a number. That's why it has extra parentheses. And then the same thing with this one. The negative sign and the plus 5, these are both horizontal, but I had to take them out. I had to like pull the negative out for you to do it correctly. So that's why there's the extra stuff there. This is going to be due Thursday night. So if you do have questions, you can still come in and ask me during block day. Or, you can send me messages on email or inbox as well. All right.